Okay, today we're going to talk about atomic math, or the math we do when we're talking about atoms. Now, first off, we want to remind ourselves that the number of protons is the atomic number of an element, and the number of protons identifies the element. So if you change the number of protons, you're now talking about a whole different element. Now, this doesn't happen in chemical reactions. So all you really have to remember is that you can't change the number of protons, because then we're talking about a nuclear reaction. The mass number is the number of protons plus the number of neutrons. Now we're only adding up these two particles because remember the electrons are almost massless. They do have some mass, but it's so little that we can effectively ignore it. Now the mass number is written after the element name or as a superscript to the left of the symbol like you see here. There's helium with a mass number of 4, it's on top, and sometimes you'll see right below it the atomic number written as a subscript. Now, isotopes are atoms of an element. They have the same number of protons, so they're all part of the same element, but they have different numbers of neutrons. So they're going to have different mass numbers and different physical properties. All naturally occurring elements have at least one, and very often more than one, isotope. And the symbol is a symbol for a couple of common ones that you've probably heard of carbon. And this is how you write it. You'd write it out carbon dash, that's a dash, not a minus, 12, and that's the mass number. And here's another isotope that's carbon 14, meaning that it must have 2 more neutrons. Or you could write it out like the symbol as we did on the previous slide. Ions. Chemistry is really more than the study of atoms, it's more the study of ions, because an ion is when an atom has gained or lost an electron, or more than one electron, so that now has a charge. And it gains and loses electrons during chemical reactions as it's bonding with other things. And of course, that's what chemistry is interested in. Now, you get a charge, an atom becomes an ion, when the number of protons don't equal the number of electrons. If they're equal, then they cancel each other out, and the atom's neutral. If you have 3 protons, you've got a +3 charge. If you have 3 electrons, you've got a -3 charge. +3 and -3 equals 0, no charge. But if they aren't equal, then you will have a charge. Now, how do you figure out the charge? It's just the number of protons minus, and it's always minus because remember electrons are negative, minus the number of electrons. And that'll tell you what the charge on the ion is. For example, you've got an ion of nitrogen. Now, because it's nitrogen, it has 7 protons. Remember, ion, isotope, or neutral atom, if it's got 7 protons, it's nitrogen. And this particular ion has 10 electrons. So 7 minus 10, that means that this nitrogen ion has a -3 charge. So it's perfectly all right to get negative numbers on these. Another example would be sodium. Sodium likes to lose 1 electron, so it'll have 11 protons and 10 electrons and a +1 charge. Chlorine is just the opposite. It likes to gain an electron, so it has a -1 charge. So let's try one of these. Let's look at the symbol here, and let's determine the number of protons, neutrons, and electrons. The number of protons is easy. You've got the symbol, you just look it up on the periodic table. If it's hydrogen, it's got to have 1 proton. It can't have anything else. Now the mass number in this case is actually given for you. It's right there. Now remember, on a test, very often students will know this is an important number, and they can't remember if it's the mass number, the atomic number, the charge, whatever. Make certain you know where all these parts go. So in this case, the mass number is given, and it's just a 1. Now to determine the number of neutrons, you're going to go the mass number minus the atomic number, or the number of protons. So in this case, that means 1 minus 1 is 0. Hydrogen is the only element that naturally has isotopes that contain no neutrons. Now, since this has a positive charge, that must mean that you have fewer electrons than protons, because protons have a positive charge. If you had more electrons, then you'd expect it to have a negative charge. Also, if you see just the sign here, just the plus or minus, and no number behind it, that means it's assumed to be 1. So in this case, this is actually a +1 charge. Now that means the difference between the number of electrons and the number of protons is 1. So you go 1 proton minus the 1 electron, 0 again. This ion has no electrons. So think about it. We're talking about an ion with no electrons. It also is an isotope with no neutrons. This is really just a proton that's hanging out in space. Okay, what if you give them the charge and I ask you the number of electrons? Okay, you look at the charge, you reverse the sign because remember, we're talking about electrons. Electrons always do the opposite of what you think because they have a negative charge. And you add it to the number of protons. How many protons it have? You just look on the periodic table. If it's oxygen, it must have 8 protons, plus, not minus, 2. This ion has 10 electrons. Okay, so here's your turn. Take a look at this symbol here and determine all the pieces, parts of it. The number of protons, neutrons, electrons. Is it an isotope? Is it an ion? Both, neither, whatever. Okay, protons. Protons are easy. If it's fluorine, it's got to have 9. Neutrons is the mass number minus the number of protons. 19 minus 9, even I could do that without a calculator, and that's 10 neutrons. The electrons, remember that's a -1, but we're going to change the sign of it and add it to the number of protons. 9 plus 1 gives you 10 electrons. It does have a charge. If it has any kind of charge at all, it's an ion. And the number of protons do not equal the number of neutrons, so it's also an isotope. One last one, take a look at this one and find all the pieces, parts of this one. Again, just from looking at the periodic table, you know that the number of protons is 58. The number of neutrons is going to be the mass number, 140, minus 58, which will give you 82. The number of electrons is, you're going to look at that right there, but remember we're going to change the sign on that. So instead of adding 4, we're going to subtract 4 from the number of protons. So it becomes 58 minus 4, which is 54 electrons. Now it has a charge, so it's an ion, and the number of protons certainly doesn't equal the number of neutrons, so it's also an isotope. And that's pretty much all you need to know about atomic math.